What are electric and magnetic fields in electrical engineering? Imagine invisible forces shaping the world around us, powers that make our devices work and our energy flow smoothly. These are the electric and magnetic fields that form the foundation of electrical engineering. Electric fields are created by electric charges or voltage differences. They reach out into space, exerting forces on other charges nearby. Think of them like invisible lines of influence that tell charges how to move. The strength of an electric field depends on how much charge is present and how far away it is. For example, a charged metal object or a battery creates an electric field even if no current is flowing through it. These fields are essential for understanding how electricity travels, how capacitors store energy, and how insulation works in wires. Magnetic fields are a different but related concept. They are generated when electric charges move, such as through a wire carrying current. Magnetic fields form closed loops around the conductor, like invisible rubber bands wrapping around a wire. The strength of a magnetic field is measured in units called Gauss or Tesla. When a device is turned on, it produces a magnetic field that can influence other nearby currents or magnetic materials. Think of a refrigerator magnet or an electric motor, both relying on magnetic fields to operate. Magnetic fields are vital in transformers, which transfer energy between circuits, and in motors and generators that convert electrical energy into motion or vice versa. In electrical engineering, electric and magnetic fields are closely connected through the rules of electromagnetism. When electric fields change, they can create magnetic fields, and when magnetic fields change, they can induce electric fields. This relationship is described by Maxwell's equations and Faraday's law of induction. It explains how wireless communication works, how transformers transfer energy, and how electric motors spin. Practically, these fields determine how energy moves through power lines, how devices operate, and how electromagnetic interference can be minimized. For example, in a transmission line, electric and magnetic fields spread out from the wire, carrying energy over long distances. Inductors store energy in magnetic fields, which helps smooth out electrical signals. Electric motors use magnetic fields to produce motion, turning electrical energy into mechanical work. Understanding these fields helps electrical engineers design systems that are efficient, safe, and reliable. They control the invisible forces that make modern electrical technology possible.